So today's topic is advanced T-SQL. So we all know what SQL is. It is structured query language. So it is a language through which we interact through databases. T-SQL specifically, which means Transact SQL, is a module which actually works for Microsoft side of databases. It's just the normal any other SQL, but it has its own, let's say, few spices in it to for some specific tastes. Just as simple as that. So we are going to understand following topics. We're going to cover following topics. We're going to cover subqueries. We are going to cover common table expressions, CTEs. We are going to cover aggregating data. Then we are going to go for some SQL constraints, primary keys, foreign keys. Then we are going for indexes. Then we have set priorities. Then we have window functions and ranking functions. Cool. So the first one is subquery. So what is a sub? I guess majorly we have the knowledge what a query is, just for starters. Yes, no. I'll take yes for an answer if anyone is not saying no.
What was your question, Rishabh? I missed that.
Do you know what is a query in SQL?
A query. Okay, so through which we can retrieve the data or update the data.
So query is basically through which we can interact with the database.
Yes.
Just take the SQL the English meaning of it. What is a query? When you have a question, right? So it is basically a question which you raise for a database. So what is a subquery then? So a subquery is basically a sub question inside the main question. So as you can see, it is written as subquery is a query that's nested inside another query in SQL. So a subquery is that query which is part of a whole bigger query. Okay. So it can be of different formats. You can filter out some specific data. You can do different things. So it is a powerful feature that allows you to perform complex queries by breaking them down into smaller, more manageable parts. It can be used in various parts of SQL statements, including where clause, from clause, select clause. So I'll give you a demo of it now. Right now I'm using a SQL editor. So let's say I have customer table, which is mentioned here. So I wanted to know all the customers whose names start with J and whose age is over 31. Okay, so I'm going to write a subquery for this. Select star from. So I'll give you example of each one of it. Well, first I'll give you the example where we are creating a subquery for the main table part, like with the from statement. This is the first query where it will return me all the names starting from J. We have two names, right? So we got John Doe and John Reinhardt. Cool. Any questions here? Now I want to use a subquery in my where clause. Okay. So what I basically want to understand what all customers have placed the order. Okay, so I want their names. Cool. So let's use it in a where clause. So I want the orders placed by these two customers whose names start with J. Okay. So I'll be writing select star from orders. where customer ID in this, and we're going to take out distinct customer IDs. Now these three orders are placed by our John Doe and John Reinhardt. Questions here? Guys, you can ask anything. It's not like if it's about subqueries, maybe you don't know what a like statement is, I'm ready to explain it. You don't know what an in statement is, I'm ready to explain it. I guess most of you have these things clear, so let's move forward. CTE. So CTEs are basically a similar structure to a subquery, but it allows you to define a named query that you can refer multiple times in the same SQL statement. Okay, so talking simply what a CTE is. So CTE is basically creating a temporary table and using it directly in the next statement. So CTE is only valid until it is used in the next statement before creating it. Sorry, after creating it. Okay, so it can also make them more efficient by reducing the number of times you need to execute the same subquery. I'll give you an example for that. And CTs are defined using with clause, as they can reference other CTs or tables with the same query. Okay, so I'll give you an example of CT. Right here is a CTE selecting order IDs from our orders table. The item ID is 5. So when right now we saw that we actually created a subquery for the from statement and for the where statement as well. So rather than writing multiple subqueries at once, sorry, yeah, rather than writing multiple subqueries at once, like writing a specific subquery for from statement, then writing the same subquery for where statement, what I can do, I can directly create one CT and I can reference it multiple times. Okay, let's remove the order ID and let's try customers. Okay, let's take the customer ID. Customer. Okay, now we're going to get all the customers which have order ID as 5. Now let's use this query. So I want to know all the customer name who have placed orders for the order 5. Okay, so I'm going to write select star from customers where the ID in CTE underscore ID. Sorry, select star from Right. No such column. Sorry. Oh, sorry. Customer ID. So now we are able to know that Luna has placed order for this specific one. Okay. I can also create a CTE for multiple columns and I can join it here as well. So if I directly query this CTE, the output would be only the customer ID which came in. So we have applied the filter of order ID 5. 5, we have one customer which is 2. So it gave me the output. So it is basically kind of a temporary table, but it is only valid up till here to the next statement. If I try to use this after this, it will say CTE ID not exist. No such table CTE ID because it is only valid up till the next statement only. You can also define multiple CTEs at once, but then you can only reference them until the next statement. So you can define another CTE by writing as comma underscore CTE underscore. Let's say now I wanted to get the shipping details, the customer of shipping, whose things have been already shipped. You can reference it like this. Comma, by applying a comma, I'll be able to know. So like okay, so now I wanted to know, does customer whose order ID is 5, is his order shipped? So let's write a query for it. Worry about the joins. I'll be adding in few joins, or I'm going to explain it in the further topics. So now what I did, add in a join CTE ID, which is the first CTE on data. ID ID. So now when I execute it, I'll be able to know the customer whose order is being shipped. And let's say I wanted to know that what is the shipping status for that specific customer. Okay. So let's take the shipping status as well. Status. So this thing would give me an output that what is the shipping status and what is the name of that specific customer as shipping status. So this is the customer and this is the shipping status of its ID, of its product basically. So it is pending, right? We can see for 5 it is pending. Any questions here, guys? Yes, no, maybe. Just make it some more interactive. Anyone has any questions? Abhishek, Aditya, Sakshi, Samriddhi. Allow to talk to people.
No questions. You can go ahead, I guess.
So again, I'm going to show you that thing as well, that you can't execute it after the CTE. That it can be only executed after, just after the CTE, not much later. So if I try to execute it here, it won't work. Well, say CTE doesn't exist. No such table as CTE ID. So these are CTEs. So again, just to recap, CTEs are a temporary tables, or similar to subqueries, what I told you, but it can be referenced multiple times. So I can create a self join and I can create multiple things. So I don't need to write that query again and again. I wrote it once and I can just reference it through the CTE name. Benefits of CD: it helps us in code reusability. So you can reuse the code again and again. If you have some complex query data, then you can write it down once and you can reuse it multiple times. So you can reference it through joins, you can reference it in where conditions, you can reference it in from conditions. So rather than writing that big complex query again and again, you just need to use that CTE name. It will work as a table only. Readability: it improves the readability of queries by breaking them down to smaller and more manageable chunks. So it breaks them down. You can have multiple CTs for a larger query, and you can reference each and every specific chunk for whatever specific data you need. And it also improves the query performances by reducing the number of times a subquery needs to be executed. So let's say you wrote 2 subqueries in a statement, okay, which is somewhat same. So it needs, when it goes to the engine, the SQL engine, it need to
And
execute those. Sorry, anyone has any questions? Anyone is saying anything? So it basically helps by improving the performance by reducing the number of times subquery needs to be executed. So let's say you added a subquery in a from condition, you added a subquery in a where condition, and everywhere you have added a subquery. Okay, so number of times you have added that subquery, the SQL engine needs to execute each and every subquery, which is like an additional task to it. But let's say you created a single CTE and you're referencing it everywhere in your select query. Let's say you have added it in the from statement, you have used it in the where clause, you have used it in a self join. But in that case, the query needs to be executed only once and it needs to be stored in a temporary storage in a CTE. So it basically improves the performance. Now moving on to grouping functions. So grouping functions and aggregating functions. Grouping and aggregating functions in T-SQL are used to summarize data in table by grouping the data into categories and then performing calculations on those groups. Okay. So there can be group by statements, sum, average, min, max, count. So we'll go one by one. So just go by their English meanings. Okay. Don't think that these are SQL functions right now. Just go by the English meanings. Group by. let's say I wanted, I asked someone in the, let's say I asked Abhishek. Abhishek, I say to you that Abhishek, you need to. We have 11 participants, and you need to group them by their age. So what you are going to do?
I would say I might not be able to answer. So basically, what I'll do on a common basis is first of all, need to find out the ages of all the participants, and then we'll use some sort of function to
No,
group them.
no, no, leave the SQL part or the coding part of it. Just a logical question. We have 11, we have 10 members. We want to play a game. Okay, so I want you to
Okay,
create teams, 4 teams
got it,
based on
got
the
it, got
age
it.
group.
Right,
Okay,
right. So.
so what
Uh,
you're going to do?
Right. So what we can do is we can create some sort of groups. For an example, people who are under like between 20 to 25 or 15 to 20 like this. Yeah. So like we can either create a group of these ages, or we can take an exact number. For example, how many people are of 25 years of age or 22 years of age like this.
Yeah. So basically, let's say we have an age group of 20 to 30 in this session. Okay.
Yeah.
So what we'll do, we create 4 groups. Okay. So our first group is 20 to 24, or let's say 23. The next group is 24 to 26. Okay. The next group is 26 to 28. And the last group is 28 to 30. Okay. So, and now the people are actually grouped by their specific ages. Okay. Now the people are who are age 20 to 21 or 23, they belong to a specific group. This is what grouping by means. Grouping records based on some specific category. Okay. So now I'll tell you how we are going to do it. So I'll write a query. Let's say I want to know all the people whose name starts with the letter J. Right? Okay. So I'll write the query. Select first name. Let's say, or who I want to know the name of the people whose name are John. Amount of first name from customers grouped by first name. So what query I wrote here? Just take the English literal meanings of it. I took the first name, then I took the count of first name, and I've created the group. And what is the category? It is the first name only. So what it is going to do, it will take each first name and it will count all the common entries for that first name. Let's say it took John. It checks one entry is available for John, then Robert. So this doesn't match. David, then this doesn't match. Then again one entry for John. So total number of entries for John is 2. I'll run this. I'll show you guys. So you can see here, first name is Betty, and Betty is repeated only once. So there is only one customer with the name of Betty. David, there is only one customer with the name of David. John, there is only one customer. Oh, sorry, there are 2 customers for the name of John, which is John Doe and John Reinhardt. Then Robert, there is only one customer for the name of Robert. Okay. Now I wanted to know that for how much amount did all the customers have placed their orders. Okay. So what is the order value for each customer? I wanted to know that. So we'll go to the orders table. We are going to, so guys, clear with this query, right? Counting and all. Just give me a yes.
Yes, yes.
Okay. Now we are going to check for orders. So I want to know what is the average order value for all the customers? What is the total order value for specific customers? So what we are going to do, we are going to take the sum of amount and we are going to group them by the category customer ID. So this will let me know that for how much amount does this customer have placed the order. So now I can see that customer 1 has placed the order for 400 rupees. Customer 2 has placed the order for 250 rupees. Customer 3 have placed the order for 12,000 rupees. And I can see customer 4 had made two orders, 400, 300. Okay. So he had made the order for 700 rupees. So I can also count how many orders did he actually make. I can count order ID as well. So now I can see that customer 4 has placed two orders, customer 3, 2, and 1 have placed one order each. Right? Clear?
Clear.
Now let's say I wanted to understand what is the average order value. So I'm going to use the AVG function. So average for customer 1 is 400 because he plays a single order. For 2 is 250, 3 is 3000, but for 4 it's 350 now. So what it did, it took out the average of for each of the customers. So category of averaging is customer. Okay. Amount is basically what we are averaging. Clear, guys?
Clear.
Anyone has a question? Anyone else? I'll take no as an answer then. Cool. So I have some average. Min max is basically taking out the minimum and maximum values. Count I've already told you, counting the records. These are just some function is used to calculate the sum. Average is used to calculate the average. Min max is basically calculating the minimum and maximum value. Count is basically counting a specific number of records. So now we are going to talk about SQL constraints. So SQL constraints are used to specify rules for data in a table. Okay, so it helps us to set up some specific rules for a table. Constraints are used to limit the type of data, like adding where clauses, adding different kind of like clauses. These are SQL constraints. So these constraints are used to limit the type of data that can go into the table. So basically, it limits the type of records entering in a table. Okay, so if I'll say some of the fields in a table cannot be null, so I won't be able to put in null values in it. Okay, so if there are any violations, the action would not take up. Right? Constraints can be column level or table level. Column level constraints apply to columns and table level constraints apply to the whole table. So these are the constraints. There's a not null constraint which ensures that a column cannot have a null value. Unique constraints, it tells that all the values inside the column need to be unique, or is unique means they need to be different and they should not be same. Then primary key, a combination of a not null and a unique. So the combination of a not null, so the value is not null in that column and it is unique. That will serve as a primary key. So it helps us to uniquely identify that row inside the whole table. Let's say I have a table of 1 million records. So there need to be a primary key which helps to distinguish each and every record from the other record. Foreign key, this prevents action that would destroy link between the tables. Check, it ensures the values in a column satisfy a specific condition, and default is basically it sets a default value for a column if no value is specified. So I'm going to give you an example for constraints now. Okay, so these are the not null constraints. So I'm going to create a table persons. Now, as you see, I have added not null constraints. So I'll try to add null value in this table. Not null constraint failed person dot first name. In first name, we were adding a null value, so it didn't even took in the entry. The table will be empty. You can see here, table is empty. But let's say now I write here Rishabh. You can see an entry has been made in the table because now it's satisfied. Okay. Now I have already created this table. So we have used SKU as unique here. So the constraint on SKU is unique. The constraint on name is not null. So let's try to execute these two values together. So as you can see, I have added the same SKU name, but as per unique constraint, the entry should be unique for that specific column. So common entries could not be fed in into that column. Okay. So I executed it. It gave me unique constraint field because the both of these entries are same. So let's rename this one 232 312. I was able to add both the records. Right? Any questions? Okay. So now I am going to define a primary key. Let's say orders already exist, so I'll add another order S. Create a table orders. I'll be adding these entries. So I have made the primary key as 1. Okay, so let's take the first two. So remember, guys, what is the rule of a primary key? It's need to be not null and it needs to be unique. So I can see that here the primary key is 1 and 1, which is same. So it is not unique. So table won't allow me to add the second entry. So let me add first entry. Let's add this one. The table allowed me. Sorry, I added another rest. So it allowed me to add one entry. Okay, you can see one entry is added. Now let me try to add another entry which has the same ID. This time it doesn't allow me to enter because the entry is not unique. Unique constraint fail order ID. Because I made it a primary key and the two major constraints for primary key is it shouldn't be null and it should be unique. Now let's try adding null. Sorry, just a second. Okay, it is allowing null, but this also doesn't happen. Okay, maybe this is the online editor, that's why it allowed null, but it shouldn't be null because primary key is something which helps us to specifically identify a record in the table. So it shouldn't even allow null. So this is an online editor, maybe that's why it is allowing, but it is not allowed when you're doing it in SQL Server. So let's create a foreign key. Okay. I'm creating a table order items and I'm creating a foreign key based on the table orders. Create it. Now you can see this table is being created order items. What I'll do, I'll add in some records into order items. I'll add in all these records. So just remember this, we have added foreign key constraints over order ID and product ID. I'm adding in these values. The foreign key constraint has failed here. I need to understand which query failed. So here the unique constraint is failed. Basically on both 1 and 1, same order ID is the same product ID is available. So the unique constraint failed here, right? That's why we are not able to add another entry. Let's try to delete from orders where ID equals to 2. Delete the ID equal to 1. It says foreign key constraint failed. So foreign key, basically it says that if you are going to delete this, then the entry inside the order item table would be invalid, because we have actually connected these two tables through a foreign key. So the order ID which we are taking in here, it is referencing the main table orders, right? So it says if you are going to delete this, this reference wouldn't make any sense, which would disrupt the integrity of the tables. Okay? So that is what a foreign key is. These are check constraints. We are going to add in a check constraint. Check constraint basically let me enter only those values which are basically on the specific order. So you can see I've added a check over salary. Salary is greater than 1000. So if salary is greater than 1000, it will allow me to add a record. Let me put it this way. I've added salary as 1500 here. So it allowed me to enter a record. But let's say I put salary as 800. Check constraint fail, because salary is needs to be greater than 1000, which we have already added in that constraint, right? Check constraint is basically checking for some that I need to have some specific rule for a specific column, so I can put it inside check constraint and will not allow it to enter. Okay, now I'm going to tell you about the default constraint. Let's say I put this as created this table. Okay, so the table says messages. Right now this table is empty. So now I'm only going to enter ID, sender, recipient, and message text, and the maker will automatically be populated. Let's insert this. I gave Alice, Bob, hello, how are you? And maker already entered automatically. It came in as Rishabh. Right? So default is something which means the value for this column can be auto-populated, but you can also enter values in this column. So default is something that this is what we are putting in, but you, if you want, you can update this as well. So let's say I wanted to put Abhishek here. This time I'll take Abhishek into that column. Okay, so I guess default ones are not taking the inputs here, but default columns takes the input. You can actually update them as well. Next topic. Now we're going to talk about, I've already told you the constraints. Now we're going to talk about the SQL Index. SQL Index is a database object that helps speed up the process of querying and retrieving data from tables. So it basically helps us to get faster results from queries and retrieving data from the tables. So index are created on one or more columns, and it contains a copy of subset of the data in those columns and organized in a way that allows for faster data retrieval. So index is stored separately from the table data using a B-tree data structure. An index entry contains a copy of the index column values along with a pointer to the corresponding rows. By following these pointers, the database engine can quickly retrieve the necessary data from the table. So index basically, it's kind of a ordering. Okay, it orders the data in a specific format so that when referencing it, it just took take the pointers of those specific data out, and it helps you give the specific data more quickly based on the pointers. There are two types of indexes. There's cluster index, then there are non-cluster index. So a cluster index is a type of index that sorts and stores the data in the same order as the index. Okay. So in the order in which the index is created, it will sort the data in the same order only. Okay, so the data will be sorted. When a cluster index is created on a table, the data is physically reordered based on the index key. So what happens? When you create a clustered index over a table, let's say it's one, we have created over id, and ids are like 1 2 3 4 5 6 7 8, and the index is also like 1 2 3 4 5 6 7 8, or let's say the index is 8 7 6 5, or in the descending order. So what it will do, it will change the physical, it will reorganize the whole data and change the physical indexing or the physical organization of the data into descending order. So once you perform a select over that, the output will be in descending order. Okay, and when clustering is created on a table, the data is physically reordered. I told you this only. Then now the non-clustered index. A non-clustered index is a type of index that creates a separate structure. So in the clustered index, the physical reordering actually happens inside the table, and the index is even stored inside the same order inside the same table. But in non-clustered index, the index is stored in a separate structure. A whole separate structure is created to store that index. So for cluster index, inside the same table the index is created, but when talking about the non-clustered index, it creates it in a different data structure which actually points to the main table. In a table, only one cluster index can exist, but we can have multiple non-clustered index in a table. Okay, so I'll give you an example. We created these columns, these tables. Okay, creating a table stocks, I'm putting in these values. Okay, now select star from stocks. Right now you saw what the order is, right? No dates are sorted, nothing is sorted, it just came out like a normal query. Okay, where is stocks? This is the table. Now I will create a cluster index on trade date. Okay, so it took just the index. The index is created. Is not sorting. Not able to create a clustered index inside this. Let's try for non-clustered now. Maybe I'll be able to do it. So guys, this editor is actually not supporting the clustered and non-clustered indexes. So I have given you the reference though. What does that mean? In the next session, we'll show you the demonstration as well. I apologize for this, but the point is clustered index is the physical reordering of the data inside the table. For the index, let's say, I'll tell you how it would come up. Okay. So when we have created a clustered index, what it'll do, it'll let's say I've put out a trade date. So it'll do is it'll give you the trade dates in the descending order whenever you select star from it, and it will also physically reorder the data inside the table as well in the same format. So I'll show you the output. Let's like I'm not able to query the data, but I can show you the output. So let's start from start. Where trade date, sorry, not where trade date. It'll store the data. So when I create a clustered index, it'll store the data in this format. It'll make the data in descending order. Okay. And the physical reordering as well inside the table would be in descending order then. But when we talk about non-clustered index, it will not sort the data inside the table, but will help in the only in the faster retrieval through the pointers. So let's say I wanted to get the data for the ones which start with 7. It'll give me sorry, which ends with 7. It'll give me those which ends with 7 through the pointer mechanism. Okay. So following things should be kept in mind while using the index. Creating unnecessary indexes on table might slow down the query process. So if you create multiple clustered indexes, that means multiple operations for a SQL engine. That will slow down the process. They can also negatively impact the data on data modification operations, insert, updates, and deletes. A table can have only one clustered index that I told you, but can have multiple non-clustered ones. Adding joins on columns which are frequently used in where clause or in joins can be helpful. Then use appropriate index type. So you should know that what specific index you need to implement. For example, cluster index works well for range queries, while non-cluster index are better for equality queries. So where you are considering range level data, use clustered index. But if you are want to equate two equations of a query, then you should use non-clustered index. Okay. When we have when we have a cluster index on table, then writing new query is slow, as it always need to be sorted before inserting in the data. So I already told you, as the physical ordering is updated in a cluster index, whenever you add a new data point inside the table first sort it as per like where it should stand inside the physical organization of the data, then it will enter it. Okay. So it will be a slower process. So it is preferred to use a non-clustered index when it's write heavy table, and use clustered index when it's a read heavy table. Okay. When you want to read more data rather than writing into it, then you should use a clustered index. But if it is like you have multiple transactions coming in every day, then use a non-clustered index. Now set operators. So set operator combine results for 2 or more queries into a single result. So what it does, it combines the results of multiple queries inside a single output. Okay, so this will help you to create unions. It will help you to create intersections of the table. Okay, the number and the order of the columns must be same, so all the columns in both the queries need to be same to get the output. Okay, the data types must be compatible. The data type also need to be same or like compatible data types. And name of the columns and results are specified by the first query. The name of the columns which will come out as a resultant would be the columns of the first query only. Nulls are equal. Okay, the first one is union. So union return all the rows that belong to at least one of the input queries. By default, result set has no duplicates. So there is two parts to the union. One is union and one is union all. So union basically what it does, it will take out the common entries from these tables and give me the resultant data set. Okay, but what there is the catch, that union would only consider one value only once. Let's say I have 32 in this table, I have 32 in this table. So when I'm going to union the age, it will give me the output of 32 only once. Okay, but if I'll do union all, it will repeat 32 twice. I'll show you one example for this. Okay, first we'll go through the slides, then I'll show you one examples. Then there is intersect. So intersect is basically it returns any distinct value that returned by both the left query and the right query, which means basically those entries it will return which is common between both the tables of both the queries. Okay, so you see union return everything irrespective of whether it is common or not. So you can see 43 is available in this table but not in this table, but union returned it. Okay, but when we are talking about intersect, it will only return those values which are common between both the tables. So let's say 32 is common between both the tables, it will return 32. 43 is not common, 30 is not common. So only 32 will be returned as an intersect. Okay, then there is except. So except is basically it returns those distinct values which are only available as part of that table only, which is not common ones. So let's go to the example again. So let's say we have this. So 32. 32 is not available in this table. So which means it will going to return 32. Then it is going to check for 43. 43 is not available in this table. It will return 43. Then it will going to check. Sorry, 32 is available. So it will not return 32, but 43 is not available. Then it will return 43. Then it will going to check 30. 30 is not available in this table. So it is going to return 30. Go by the English literal meanings. What does except means? So let's say I want I go to someone, I say give me 10 of this thing, but give me 10 balloons except yellow ones. Okay, so what I said, that I don't want the balloons which are yellow, or give me 10 balloons which is not common between the second lot and the first lot. Okay, so that is what except does. I'll give you the examples for except, like all the these functions now. So I create a table, table 1, table 2, I added the values. Let's do the union first. Union gave me distinct values, 1, 2, 3, 4. Okay. Where are the tables? T1, T2. So you say table 1, table 2. So union gave me distinct values, although the entry number 2 is repeated, but it still gave me the distinct values. It returned only 4 columns. Now let's try union all. Union all returned me 6 values, which means it took in all the values irrespective of whether they are repeated or not. Okay. Now let's try intersect. It returned me only 2 and 3 because it is common between both the tables. Okay. Let's try except. It returned only one value, Alice, because Alice is the only value which is not available in the below table. Okay, so except basically what it does, it takes out the values which are available in the first table but are not available in the second table. So it means this except these. Okay, now let's talk about window functions. I guess this is the last topic. No, we have ranks as well. Now it comes in the same only. So window functions SQL are used to perform calculations across a set of rows that are related to the current row. These functions allows you to perform calculations of group of rows in a query result without having to group the rows themselves. So if you want to create a group statement, let's say I wanted to have some specific group statement, but I don't want to apply the resultant. I don't want the resultant as a group by statement, but I want to populate some fields based on the group. Let's say I want to populate some sum, but I don't want to get. I want all the rows output, but I also want a sum column in it. Okay, so for those, we are going to use the group functions. Sorry, the window functions. Okay, there are three types of window functions. There is a row number which assigns a unique sequential number to each row within a window. Then there is rank and dense rank. It assigns ranking to each row within a window based on specific ordering. Then there are lag and lead functions. Return the value of a column from previous or next row within a window. Okay. We'll go with the row number first. So row number function in SQL is a window function that assigns a unique sequential number to each row within a window. Okay, so it will assign a specific sequential number 1, 2, 3 based on a condition what we have added. So what kind of partition what we have created and what kind of ordering we have created. On the basis of that, it is going to assign sequential numbers. Okay, I'll give you an example. So let's say I created this table. Now I wanted to get the sum based on my customer. First, I give you a row number example. Create a row number ID. So let's sorry, I have written my orders table, right? Where the data. Let's read. I have order ID. I have item ID. Let's do it with customer. Okay. So yeah, now you can see number on the ordering, on the basis of customer ordering. I have assigned my row number. Okay. So now customer one has been assigned the row number one. Guys, just give me a second. Hello. 5 minute रुक जाओ. Guys, I'm audible?
Yes, yes.
I'm audible, right? Abhishek, am I audible?
Yes, yes, you're audible
Yes, you're
now.
audible.
Let's proceed.
So, now you have seen here, I have created. So it is I have created on the basis of customer ID. So it has assigned each customer ID. I have ordered it based on this. So for one, I've assigned 1, 2, S2, 3, S3. Then for 4, the 2 entries for 4, it has assigned each entry a unique row number. Okay. So it has assigned both of them as 4. Okay. Now let's say I partition it by customer ID as well. Now you can see for each customer ID, it has given 1, 1, 1, 1. Then uh, it has 2. I asked, but first then assign in each. This is one partition, 2 is one partition, it doesn't multiple currency single part. 20 is 4. So that 2 numbers to it. One conditional sum. We are now on to amount customer IDs ordering basically. See the data as well. This is the sales. So first, one
Rishabh, I'm not sure whether this is my case. Actually, we are losing
parties.
you.
But what was the running total of 50? Added to it, and it's 450 now.
Hello, Rishabh.
Am I audible enough? Yeah.
Yes, you're audible now, Rishabh.
But your, Rishabh, your voice basically keeps on cutting in
So
between.
basically,
So
we have calculated
yeah,
happening for everyone.
like
Or
anyone else?
is this specific to someone? Anyone else as well? Let me know.
Your voice is breaking, Rishabh. Can you please check your network once?
Just, just give me a second, guys. Hello.
Yes. Mm,
Hello, am I audible now?
yes, yes, yes. Now your voice is clear.
Oh.
Yeah.
I'm sharing. So I guess we're clear with the row number, right? Or I was not able to complete. So now what we are total here. Okay, running total is nothing but adding up the sales of each last day a customer has done a transaction. Okay, so as you can see, this customer one, he has done a transaction of 100, 150, and 200. Okay, so what I did, I created a partition for the customer and I've ordered it by sales data. So sorry, sales date, and I've created a sum over it. Okay, so now you can see what the output has come out here. First day it is 150 for customer one. The next day he did 200 more, so the running total is 350. For next day he did 100 more, so the running total is 450 now. Now, so on first day did the sales of 100, so for him is 100. The next day he did the sale of 75 more, so the running total is 175. Now sale of 50, so the running total is 220. Right? Row
Rishabh,
number
are
I've
you sharing your
already
screen?
explained to you guys. Now let's talk about rank. I've shared my screen. Is it not
Uh,
visible?
Actually, it is not visible to me. I'm not sure about others. Let me check my connection once.
Not visible to me as well.
It's not visible even for me.
Yeah. Okay.
Let me reshare it.
Now it is visible.
Okay. Yeah. So I was explaining the running total basically. So I have created the partitions for each customer and I have ordered their totals by sale date and I have taken the sum of it. Okay. So for the first day, customer one did a sale of 150, so his running total is 150. On the next day, he did a sale of 200 more, so the running total came 350. Next day, he did a sale of 100 more, then the running total became 450. Now the second partition comes into the picture because now it is the second customer. For the first day, second customer did a sales of 100, so his running total is 100. The next day, he did 75 more, the running total became 175, and the next day he did 50 more, the running total became 225, right? Is it clear now?
Yes, yes.
Yeah, sorry guys, I just got some urgent phone call. Okay, so moving forward towards ranks now. So let's create a rank. Let's create a rank. This is all the details. We'll create an on the top of orders table. So I'm going to provide rank on the basis of amount, okay, for each transaction. Okay. So now you can see rank 1 is allotted to the highest one, which is 12,000. Rank 2 is allotted to the next one. As you can see, the rank is repeated for 400, 2 and 2. But the next rank which came up is 4. But ideally in the ordering, what it should be? It should be 3, right? So, but in the rank function, what it does, if it gets two common entries, it assigns the same ranks to them, but it skips the next numbers. Okay, but if there are 3 entries here of 400, then the next number which would pop out would be 5. Okay, so 3 and 4 would be skipped. But let's say if I add dense rank here, now you can see the next number is 3 only. So this is the major difference between rank and dense rank as well. Okay, are we clear on this?
Yes.
So this is the major difference between rank and dense rank. So rank skips the next value if it gets a common entry, whereas dense rank doesn't skips the next value. Okay. The ranks I've already told you. So this was the theory of it. A rank function is used to retrieve ranked rows, which I already showed you, the ranked rows, based on the condition of the order by clause. For example, if you want to find the name of the car with third highest power, you can use rank function. So you can apply the rank, like we see that I want to know what is the highest transaction or what amount is the most. So for this, it gave rank amount as 12,000 as first because I have added the rank on the amount in the descending order. And if let's say I wanted to know third highest one, so I'll take it as 2 or 3. The third highest is 3. So once I apply the filter of 3, it'll give me which is the third highest one. Same, the rank difference, I told you that it is basically same, similar to rank, but dense rank does not skip any ranks. So if there is a tie between the ranks of the preceding records, it will show the next number only for the next record. It won't skip any number. Now the lead lag functions. The lag function allows access to a value stored in a different row above the current row. The row above may be adjacent or same number of the rows above as sorted by a specific column or set of columns. Okay, so lag is basically one, just go by the English meaning. Lag is what? Just before, right? And lead is what? Just after. Okay, so what it does, it gives you the output of the row preceding the current row, the lag function. And lead function is, it will give you the output of the next row from with the current row. Okay, I'll show you one example. These are the lead and lag functions. Let's go one by one. I'll show you the table as well. Where's the sales table? This is the sales table. So I have applied the lead function on the sales date and I've ordered the sale date, or I've used the ordering on the basis of sale date. So I am taking the sale amount. Okay, I want the output of the sale amount, the lead output of the sale amount, which is ordered by sale date. Okay, let's run it. So for sale amount 100, which happened on 2022-1-1, the next lead amount was 50, which came out here. For 50, which happened on 1-2, the next lead amount was 200, which happened on 1-5. Okay, so it came out at 200. For 75, for 200, the next lead amount was 75, so it showed 75. For 150, for 75, the next lead amount was 150. For 150, the next lead amount was 100. But for 100, there was no entry which was exceeding 100 here as per the dates. So this was the last date when a sales actually happened. So for this, you can see the lead amount for 100 is blank because no sales happened after this date. Okay, so it just gives the sales of the next day as well if it's available inside the table. Let's use the lag function as well. Here you can see that nothing happened before 1-1, so the sale amount 100 doesn't have a lagging sale amount, right? For 50 it is 100, for 200 is 50, again the same order, right guys? Clear? So I'll be open for questions now. Please let me know, guys. Please let me know if you guys have any questions.